students, today's agenda is to check homework. We'll be learning about removable discontinuities, and you will be able to do 7.6. Today, students will be able to graph removable discontinuities that still act upon the graph. For number 1, it says graph, and we have y equals x plus 2 all to the second power times x plus 4 all over x plus 2. And so the first thing that we need to do is you can either expand it or just know that one of these two will cancel with this one because it's the same factor. X plus 2 cancels with x plus 2. And we're left with x plus 2, one of the ones that we have in here, times x plus 4. And since we have that cancel, we don't need to put it underneath. Okay, so our simplified equation is y equals x plus 2 times x plus 4. And if you can see, these two factors will become a parabola because we have x times x is going to be x squared. Quadratic equations create a parabola. Okay, so the first thing that we need to do is to see what will be the whole, what will be the removable discontinuity. Okay, and for that, the one that we cancel, that's the one that we're going to get. So x plus 2, equal that to 0 and then solve for x. So if I'm adding 2, the opposite is to subtract 2. And we get x equals negative 2. Then we're going to replace that negative 2 into our simplified equation. And so y is equals to negative 2 plus 2 times negative 2 plus 4. Negative 2 plus 2 is 0 times negative 2 plus 4 is 2. But anything multiplied by 0 is always 0. So the whole created by this removable discontinuity will be at negative 2, 0. Now, because this creates a parabola, we need to find some parts of it. So let's start with y, the y-intercept. And for the y-intercept, remember that x equals 0. Always for the intercepts, the opposite is equals to 0. So y is equals to 0 plus 2 times 0 plus 4. And that gives us 0 plus 2 is 2. 0 plus 4 is 4. 2 times 4 is 8. So my y-intercept is going to be at 0 for x, 8 for y. Now for the x-intercepts, remember that y is equals to 0, so the opposite. And so from our simplified equation, we replace y with 0. So 0 is equals to x plus 2 times x plus 4. Now, if you remember, once it's factor, to be able to solve this, it's just the opposite. This needs to be 0 because 0 times anything will be equals to 0. So what value for x will make this factor a 0? Well, negative 2, because negative 2 plus 2 is 0. This needs to be negative 4 because negative 4 plus 4 becomes 0. Okay, so my x-intercepts are at negative 2, 0, and the other one is at negative 4, 0. So we have our x-intercept, we have our y-intercept, we have the removable or hole created by the removable discontinuity. The only other thing that we need in a parabola, you always need the vertex. For the vertex, you need the formula x is equal to negative b all over 2a. To be able to find the vertex, you need to have this. We have to have it in descending order. So we're going to put y equals, for the first term, it's going to be x times x, which is x squared. For the middle term, remember the face. 2 times x is 2x. X times 4 is 4x. Together, 2x and 4x is plus 6x. And then finally, for the last term, you have 2 times 4 is 8. So this is now my quadratic equation. Remember that the coefficient of x squared will be the value for a, which is 1. The coefficient of x will be b, which in this case is 6. And the constant will be c. So it's 8. And we will only need, for that formula down there, we only need b and a. So b is 6, a is 1. Okay, so now going back here, negative b, we carry the negative from the formula. B, we said that it's 6. Negative from the formula, the 6 that we have up there, and then 2 times the value of a, which we said is 1. Negative 6 divided by 2 times 1 is 2, so negative 6 divided by 2 is negative 3. After we find the value of x, which is negative 3, we still need to find y. And how do we do that? We just replace it. And it can be in any of the two. It can be the factored form of the equation or the descending form, okay? So let me use the factor. So y is equals to negative 3 plus 2 times negative 3 plus 4. Did was to substitute the negative 3 into x here and here, okay? So negative 3 plus 2 is negative 1 times negative 3 plus 4 is 1, which is negative 1 times 1 is negative 1. So now I have my vertex. It's right there. Now that I have all the pieces, let's put them together. So let me see. I know that I will need, on y, I need up to 8 and negative 1. And for x, I need negative 2, negative 4, negative 3, negative 2. Okay, so mostly on the negatives. That helps me guide my graph, and so I will create it something like this. So negative 1, negative 2, negative 3, negative 4. And then I need up to 8. So 1, 2, 3, 4, 5, 6, 7, 8. And then I need negative 1 on y. Okay, so I want to include the whole first thing, and the reason is because I don't want to forget it after I do my graph. So negative 2, 0. Negative 2, 0 is right here. So that means that there's going to be a hole in there. Let me put some white out because the line of the negative 2 looks like it's closing it. So let's take some of this out because it's empty. It's a hole. Okay, at negative 2. Okay, so that's the hole. Then I start plotting in the other points. The y-intercept is at 0, 8, right there. The x-intercepts are at negative 2, 0. It means that the graph goes through there, but it still has the hole. And then the other one is at negative 4. It's right there. My vertex is at negative 3, negative 1. So you go negative 3, negative 1 is right there. And one last thing that I recommend when I don't have a guide in here, what I do is see how these are symmetrical. They're the same length away from this vertex. So that means that this point is also symmetrical to some other point in here. And I count 1, 2, and then 8 up. From this point I can count also 1, 2, and then 8 up, and it guides me so that I know this is just a point of reflection because it's reflecting on the other side. And again, it's just to guide me. So this parabola goes through this point, excludes that, it creates a hole, and then it just goes on to this point. And the same thing on the other side, it goes through here. But that one is included. And to smooth it out, I just make it wider. For number 2, we have x plus 2 times x plus 4 over x plus 2 squared. And so we notice that x plus 2 and x plus 2 are both in the numerator and denominator. And so that means that it will cancel one of these ones. So now you only have 1, which is x plus 2. So when we simplify, and I forgot to put the y in here, it's going to be y equals x plus 4. And you can put the parentheses or not, it's okay. And then over x plus 2. For this one, because we end up with a rational function, remember that for rational functions, we have certain rules for the horizontal asymptote. And so it says, if the degree of the denominator, meaning down below, is greater than the degree of the numerator, and remember that degree refers to the exponent, the highest exponent. If the one in the denominator is bigger than the one in the numerator, then the horizontal asymptote is always exactly on the x-axis, meaning y is equals to 0 because it's not going up or down on y. If the degree of the denominator is less than the numerator, there is no horizontal asymptote. It means that it goes infinitely down and infinitely up, so there is no breaking in the middle of that function. And if the degree of the denominator is equal to the one in the numerator, then you have to divide the coefficients to know where to move your, in this example, we have 3x to the first power. So the power is 1. Because they're equal, what we divide is the coefficients of that variable. Okay, not the degree. The degree just guides us that if they're equal, we divide, but we divide the coefficients. In this case, 3 divided by 1. Okay, so it moves up 3 spaces. So those are the 3 rules for the horizontal asymptote. For the vertical asymptote, it's always the same. The vertical asymptote, which goes like this, is just setting up whatever is in the denominator, equal that to 0, solve it, and say we cannot cross that. Okay, so the first thing you need to do, again, so that we don't forget, is see where that hole will be, where that removable discontinuity is. And so whatever you canceled, that's what you're going to equal to 0. So x plus 2, because that's the one that I cancel, equals 0. And I start solving for x. So x equals -2. Then I'm going to find the value of y with the simplified function already. So replace that in the x, -2 plus 4 over -2 plus 2. And so -2 plus 4 is 2. -2 plus 2 is 0. We cannot divide by 0. And I said, why? Because we're looking for, let's say that we have 2 pieces of bread and we're dividing it by 0 people. How many breads does each person get? And they say, oh, 2. And I say, who gets it? There is no people. And then they say, oh, then it's 0. Okay, and what happens with the 2 pieces of bread? And that's when it's like, okay, that's why it doesn't make sense. If you use a calculator and say 2 divided by 0, it says error. And it's just that you will never find a number that multiply by 0 giving you another integer other than 0. Okay, so that's why whenever you have this, you say undefined. Okay, so this is not a possible whole, basically, and we'll see why. Okay, so for our graph, let's find our y-intercept. Y-intercept. For the y-intercept, remember that x equals 0, so we are just going to substitute that by 0. So y is equals to 0 plus 4 divided by 0 plus 2. And 0 plus 4 is 4. 0 plus 2 is 2. And 4 divided by 2 is 2. So for my y-intercept, x equals 0, y equals 2. Then we're going to look for the x-intercept. And so y will be equals to 0. Again, we replace the y with 0 and bring that down. So 0 equals x plus 4 over x plus 2. Okay, if we're dividing, we're going to multiply by x plus 2 on both sides. This cancels, and I get x plus 4 equals 0 times anything will always be 0. Now we subtract on both sides to solve for x. And so x equals 0 minus 4 is -4. So my x-intercept is at -4 for x, 0 for y. Now for the horizontal asymptote, those are the rules that we found. And then we see that the degree here is 1 and 1. So we are going to divide because they're equal. If they're equal, you divide the coefficients. And the coefficient is also 1 and 1. So we divide 1 divided by 1 to find. So we divide 1 by 1, which is equals to 1. So that's where my horizontal asymptote is going to be. For the vertical asymptote, remember that we get whatever is in the denominator and equal it to 0. X plus 2. So x plus 2 equals 0. We subtract 2 from both sides. And so x is equals to -2. Or we can say is not equal to -2, because remember that the asymptote is like the graph it can approach it, but it can never touch it. Okay, so it's kind of like a horizontal hole and a vertical hole for those asymptotes. Okay, for the graph, just with this information, let me see what we need. The y values are 2. We have a horizontal and vertical. So it's 1 and -2, -4 on x. So we need up to -4 on x. We've been doing a lot of tables in the previous one, so I'm going to do a very simple one in this one. In here, let's go first with the important information. Y-intercept is at 0, 2, so 0, 2 is right there. Oh, and we said that we're going to do the whole first. So remember that we have for x is -2, but then we don't know, it's undefined for y, so we don't know exactly where to put that whole. So we have to be very careful with that. The x-intercept is at -4, so -1, -2, -3, -4, right there. Now the horizontal asymptote, it's at 1, means that there is going to be a line in, and that cannot be touched. And the vertical asymptote is a -2. And -2 is right here. And so again, we don't know if our rational will be on what side, but that's why these help us. Okay, so let me show you now what's going on with the whole. The whole would be at -2 and some other number, but it's undefined. Why? Because it's -2 and we don't know if it would go down or up, but it's exactly at a line where we cannot touch, we cannot cross with our graph. So it's like saying, make a hole in the hole. You make a hole in dirt and then make a hole in that hole. It's not possible, right? It's undefined. That's another way of seeing it. And so that's why we cannot graph that little hole in there. I'm going to do it with pencil. Why? Because we're not sure where those values will be. And so we know that it's going to cross through here. So the x and y intercept guide us that it's going to be here and here and not here and here. Okay, again, this graph crosses something like this. And if you want to know more points, like you can do that. And it approaches those asymptotes, but the graph never touches it. Okay. And so this will be something like that. Why with pencil? Because if you want to find some values, you can go ahead and do that. And then you will have a more accurate function or graph. So let me do some values in here. Okay, I'll just do, we know that the vertical asymptote is a -2. Then I'll do here -2.5, and then -3. On the other side, I'll just do 2. In the other videos, I used to do like 3 on each side. On the other side, since I I'm adding, or actually I'm subtracting half in here. I'm going to add half in here. So -1 and 1/2 and -1. To find those values, we're going to use the simplified form. So x plus 4 over x plus 2. And so let's start plugging in -3 plus 4, -3 plus 2. -3 and +4 is 1. -3 and 2 is -1. And 1 divided by -1 is -1. For the other one, y is equals to -2.5 or -2.5. You can work with that if you wish. And -2.5 plus 2. From the 4, you're taking away 2 and taking away half, so you end up with 1 and 1/2 divided by, now in here you owe $2.50, but you have $2, you only owe 1/2. And so positive divided by negative is negative. How many halves going to 1.5? It's 3 of them. So for this one, what you do is the top one is positive, and remember that 1.5 means 1.5. So 1.5 divided by, and then in here you have -1/2. You're going to put 0.5, press the negative, which is right here, not this minus, but the negative symbol. Press it and then press equal, and you get -3. So be careful, because some calculators you have to put first the negative and then the number, but in some others like this one you put the number first and then the sign. This is the value of this asymptote. It means that I'm going to get undefined, so I'm not even going to do it, but you can try it. You will get 0 in the denominator, because -2 plus 2 is 0, and we cannot have 0 in the denominator. For the next one, you have y is equals to -1 and 1/2 plus 4, divided by -1 and 1/2 plus 2. If I have 4 and I take away 1.5, I end up with 2.5 or 2.5. Okay, and then in here I have 2, but then I take away 1.5, then it's going to be 1/2. Here, how many halves going to 2.5? Well, from 2 I get 4, and one more, it's 5. Again, if we use our calculator, it means 2.5 divided by 0.5. It's 5. Okay. I just wanted to show you that some calculators, the negative shows like a minus in the parentheses. In other ones, you have a plus and a minus like this. Okay, the last one, you have y is equals to -1 plus 4, -1 plus 2. 4 minus 1 is 3. 2 minus 1 is 1. And 3 divided by 1 is 3. So now I have the values so that I can see how close I was with that graph. The first one is -3, -1. So -3, -1 was right there. -2.5, -2.5 is right here. -3, so 1, 2, 3, right here. And you can see that it's a little off. Okay, on the other side, we have -1 and 1/2, so -1 and 1/2, and we have 5. So 1, 2, 3, 4, 5. That one's closer. And -1, 3, -1, 1, 2, 3. Oh, I was right on the dot. So this is going to be my graph. And you can actually find other values in here to see where it crosses. We did that for the previous videos, and you can try that now on your own. Okay, for this one, let's correct it a little bit. Somewhere in here. And then again, you can do more values in here so that you know where does it go. So in here we can see that the whole we were not able to graph it because it's a hole on this hole, vertical hole, and so you can dig a hole in a hole. With this, we end our lesson. We will greatly appreciate a thumbs up. Also, if you subscribe in here, you will be supporting our channel. This is the link to the entire unit on graphing different parts, different types of higher degree and rational functions. Here you will find the next lesson. Now you're able to do 7.6 and
have fun. This is not Loopy's hand. This is Shadi's hand.